we've just seen that in the case when an element has more than one isotope, the relative atomic mass is the weighted average of all of the isotopes. In these instances, we can use a formula in order to calculate the relative atomic mass, which is that the relative atomic mass, or AR value for an element, is equal to the sum of what is known as the isotope abundance multiplied by the isotope mass number. And this sum of isotope abundance multiplied by isotope mass number is all divided by the sum of all isotope abundances. We can see what all of these terms mean by looking at an example. Our example of an element that exists as more than one isotope is the example that we just looked at, chlorine. We saw that chlorine exists as two different isotopes with mass numbers of 35 and 37. We said that 75% of all chlorine atoms have a mass number of 35 and that 25% have a mass number of 37. These percentages are known as our isotope abundances, telling us about the relative amount of each isotope that is naturally present within our samples of chlorine atoms. If we look at our formula for calculating the relative atomic mass, we can see that we have all the information that we need in order to calculate the relative atomic mass of chlorine. So, our relative atomic mass, or AR value for chlorine, is going to be equal to the sum of isotope abundance times isotope mass number for each of the possible isotopes. So, in the example of chlorine, we have two possible isotopes, and for each we have an isotope mass number and an isotope abundance. Therefore, the numerator of our fraction that allows us to work out the relative atomic mass is going to be firstly the isotope abundance of our first isotope, which is 75%, multiplied by the isotope mass number for this isotope, which we can see is 35. To this, we then add an equivalent value for our other isotope, for which the abundance is 25% and the mass number is 37. The denominator of our fraction for the relative atomic mass is then the sum of all the isotope abundances, which in this case is going to be 75% for the isotope with a mass number of 35 and 25% for the isotope with a mass number of 37. We are now ready to calculate our relative atomic mass.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.